Electronegativity is the tendency of an atom to attract the bonded electron towards itself and is denoted by the symbol Xi. There are many scales by which electronegativity is measured. Number 1. The Mulliken Scale. Robert S. Mulliken proposed that the arithmetic mean of the first ionization enthalpy and the electron affinity or electron gain enthalpy should be the main method of calculating the power of an atom to attract electrons to it. So he came up with a formula like this. Number 2. The Allred-Roto Scale. Introduced by A. Lewis Allred and Eugene G. Roto, they considered the electrostatic pull by the effective nuclear charge on the outer electron and laid down a formula like this, where this is the effective nuclear charge and this is the covalent radius in picometers. Number 3. The Pauling Scale. This was proposed by Linus Pauling in 1932. He observed that the bond dissociation energy of a molecule AB is always greater than the geometric mean of the bond energy of AA bond and BB bond. He found the difference between the two and equated it with the difference in electronegativities of A and B like this. Electronegativity of fluorine was highest and set at 3.98 in order to ensure positive electronegativity of all the elements. Electronegativity depends on factors like nuclear charge, atomic size. As nuclear charge increases, the electronegativity increases due to increased pull on the valence electron. As atomic size increases, electronegativity decreases due to valence electron is now further away from the nucleus, with the inner shielding electrons contributing to a repelling effect. Periodic trends of the elements is shown here. All the electronegativities are given in Pauling scale. It increases across the period due to increase in nuclear charge and decreases down the period due to increase in atomic size. Not here in group 13 and 14. This is due to D block contraction. Lead has unusually high electronegativity when compared with thallium and bismuth. This seems to be an artifact of data selection because when electronegativity of lead was measured by Allred-Roto formula, it was found to be 1.55. Electronegativity difference of two atoms in a chemical bond determine the type of bond. If the difference is small, then the bond is covalent. If the difference is little bit more, then the bond is polar covalent bond. Now, if the difference in electronegativity is appreciable, then the bond is ionic. Electronegativity depends on oxidation number. As oxidation number increases, there is an increase in electronegativity. See hypochlorous acid where oxidation number of chlorine is +1. The electronegativity of chlorine is less than that of oxygen. So the electron pair moves to this side and make the oxygen slightly negative. This slight negative charge will repel this electron pair to the side of hydrogen. This will restrict the formation of H+ and it is a weak Bronsted-Lowry acid. See perchloric acid over here. The oxidation number of chlorine is +7. Therefore, it is more electronegative and the bonded electron pair is pulled towards chlorine. So, oxygen over here has no negative charge. Thus, electronegativity of oxygen normally pulls this bonded electron pair towards itself and therefore facilitates the formation of H+ and is therefore a strong Bronsted-Lowry acid.